Okay. So module 5 is a small module and you will have some 3-4 problems to do, and then little theory portions. Okay. And then easiest module of all the things. So first let me give you the introduction about this module. Okay. So here you have metabolic stoichiometry. Okay. So stoichiometry, as you people know, all of you know, what do you mean by stoichiometry balance? Okay. Stoichiometry balance is like balancing the equation. You people know reactants is equal to products. If you give so much of reactants, how much amount of products we will get. So that is called as what? Stoichiometric balancing. Okay. So the reactants and products should get balanced. Okay. So what do you mean by metabolic stoichiometry? Means when we will be using the microorganisms as a substrate. Okay. So you will have substrate and biomass. Okay. Substrate plus raw material will give you biomass is a product. Okay. That means from microbe we will be generating the product. Okay. So that time that will be called as the metabolic stoichiometry. So when we will call it as metabolic stoichiometry means some reactions, that is living reactions, will be taking place, and that we will be balancing. That is called as the metabolic stoichiometry. For example, if you want to produce ethanol, you will have this Saccharomyces cerevisiae, that is yeast, as the substrate. Okay. Yeast will be your substrate, and then you will be using some other compound. Okay. We have to grow the substrate. So for that we will be using as such microorganisms, that is the yeast is our microorganism of interest. And for that we will be using some other molasses or carbon source or hydrogen source. Okay. So yeast plus, that is Saccharomyces cerevisiae, plus what? Carbon source plus hydrogen source plus nitrogen source will give you ethanol, plus what? The cell biomass. The cell will be died off afterwards, the biomass. Okay. So like that, when you get the equation, that is called as what? Metabolic stoichiometry. So the difference between is normal stoichiometric balance is balancing a chemical reaction. Okay. So metabolic stoichiometry is nothing but balancing a biological reaction. Clear? Concept is clear. What is the difference between normal stoichiometric and metabolic stoichiometry? Clear, ma? Guys?
Yes, ma'am.
Okay. So, and the next is the nothing much to study about it. You people should know about that. Okay. And you have some definitions like overall growth yield efficient. Okay. So overall growth yield efficient is X represents the cell mass and S represents the substrate. Always remember. Okay. So X represents the cell mass and S represents the substrate. So the amount of cell mass produced divided by amount of substrate utilized. Okay. That is yield coefficient, Y bar X bar S. Okay. And then X bar ATP is X always represents the cell mass. Remember it. Okay. X always represents the cell mass. So whatever is in the top you will get in the numerator, and whatever is represented in the bottom you will be get as the denominator. So X is amount of biomass divided by ATP is mole of ATP generated. Okay. And all these and all is not required for you people. Okay. And the next is respiratory quotient. Okay. So respiratory quotient also that we have to do in problems. Just the definition. Respiratory quotient is moles of CO2 consumed divided by moles of oxygen consumed. Okay. So the formula for respiratory quotient is, when you are doing a reaction, respiratory quotient is moles of CO2 consumed divided by moles of O2 consumed. Okay, that is called as the respiratory quotient. And the next is P by O ratio. So that is gram mole of P divided by gram atom of oxygen. You people just study the definitions, and actually this is all not in the syllabus, but for our we don't know, sometimes they will ask this definitions. For our safer side, you will study this P by O ratio and H by O ratio definitions. Okay. So what we should know here is maximum is this yield coefficient Y X bar S, and then what? Respiratory quotient, that is RQ, that is our problems. Okay. This is what we will be using in problems. Okay. And the next is this regulatory and all is not there. And the next is elemental balance. Okay. For example, if you have a equation like this is what I told. Okay. This is one compound, and AO2 plus BNH3 gives C this is the biomass. Okay, C CH alpha O beta N gamma plus BH2O plus ECO2. Okay, so what do you mean by the elemental balances? Usually we will do the balance equation, we will do the balance. Okay, like 1 CH means how much AO2, how much B. Okay, like that we will be doing this elemental equational balance. Elemental balance means out of this we will see how many compounds are there. Okay, for example, here we are having carbon, hydrogen, oxygen, nitrogen. Okay, so three compounds here we are having overall in this equation. That is, carbon is there, hydrogen is there, oxygen is there, and nitrogen is there. Four compounds. So we will be taking each compound separately. That is, each element separately, and then we will be writing the elemental balance. Okay. So for example, for this equation, how will you write this carbon balance? Okay, carbon balance means, so you should see the amount in reactants is equal to products. Okay, so here you have CHMON plus AON2 is plus BNH3 gives CH alpha O beta N gamma plus DH2O plus ECO2. Okay, so what we should do means, first reactants is equal to products. Okay, what you should remember is reactants is equal to products. So first we will start, first element is carbon, so we will start with the carbon balance. Okay, so we should see the coefficients of this carbon. Okay, how many amount of carbon is there? Okay, so 1. Okay, what is the coefficient is 1, and how many elements of carbon is there? 1 into 1. Okay, is equal to, so here no other carbon is there, so in reactants we don't have any other carbon, is equal to, here we will see. Okay, so that is 1 into C. Okay, one element of carbon into the coefficient is C. Okay, plus again you have how many elements of carbon is 1, and the coefficient is what? E. Okay, so the carbon balance for this equation is 1 is equal to C plus E. Okay, like that you have to write. And the next is hydrogen balance. Okay, so here the coefficient is m number of carbon, and the coefficient is 1, m into 1 plus, okay, so here you have B 3 hydrogen. Okay, 3 into B. Okay, so no where hydrogen is present, so 3 into B is equal to, okay, so here we don't have hydrogen, but here we have hydrogen. Okay, sorry, here we have hydrogen, so alpha into C, okay, plus 2 into 3. Like this you should write the hydrogen balance. And the next is nitrogen balance. Okay, oxygen balance we will write. So how will you write? N into coefficient is 1, so N into 1 plus, you have 2 oxygen, and the coefficient is 2 into A is equal to, okay, so beta into C, beta into C plus, okay, 1 into D plus 2 into E. Okay, so this is called as elemental balance. And the nitrogen balance, how will you write this? So here only, here you have nitrogen, so 1 into B is equal to, here you have, so gamma into C. Okay, so nowhere else nitrogen is there, so this is called as the elemental balance. Okay, an equation is being given, and how we are going to balance the equation. Okay, that is called as what? Elemental balance. So here you can see hydrogen balance, oxygen balance, nitrogen balance. Okay, so and I have told a formula of respiratory quotient, that is moles of CO2 produced by moles of oxygen consumed. So if you check in this, moles of CO2 produced is how much? E. Okay, and the moles of oxygen consumed is A. So the respiratory quotient for this equation will be E by A. Okay, the respiratory quotient for this equation will be E by A. All of you understand this elemental balance mass. So you will be given an equation and you will be asked to do the elemental balance. Means first you should check how many compounds are there. Okay, so here you have carbon, hydrogen, oxygen and nitrogen. Okay, four compounds are there, and separately you have to write the balance of each. So how will you write the carbon balance? The amount of carbon in reactants is equal to the amount of carbons in products. So here first we will check. So coefficient is 1, okay, and C and 1 mole. So 1 into 1, and you don't have anything else in the other carbon other than one place, okay, is equal to alpha 1 into C plus 1 into E, okay, like that. And next hydrogen means 1 in M into 1 or 1 into M also you can write, okay, M into 1 plus 3 into B gives, okay, alpha into C plus 2 into D. Same way we have written for oxygen and nitrogen. So this is called as the elemental balance. Okay. And the next is respiratory quotient. Respiratory quotient is moles of CO2 produced divided by moles of oxygen consumed. That's what. So here moles of CO2 produced is E and the moles of oxygen consumed is A. Okay. So E by A. And if it is given as like problems has been given with numbers, so accordingly the coefficients will vary. And the next important concept here is degree of reduction. Okay, so first is yield coefficient, and the next is elemental balance, and the next is degree of reduction. Okay, so this degree of reduction is usually basically used for proton electron balances in bioreaction. Okay, so what is the formula for this degree of reduction is, okay, so degree of reduction is number of equivalents of available electron divided by gram atom of carbons. Okay, number of equivalents of available electrons divided by gram atom of carbon. Okay, so here this concept is totally different than the yield coefficients and then what this respiratory quotient. For example, we have to study number of degree of reduction formula is number of equivalents of available electrons divided by gram atom of carbons. Okay, so remember here you will not multiply with the molecular weight and all, just we will be identify the available electrons. Okay, so here for example they have given calculate the degree of reduction for the following substrates. Okay, so CH4, C6H12O6, C2H5OH. So the formula for degree of reduction is number of equivalents of available electrons divided by gram atom of carbon. Okay, so CH4 available electrons is, what is the available electrons is, so 1. Okay, so elemental balances you people should know. Okay, for that you people should know about the elemental balance. Okay, elements, see carbon is 4, you people know hydrogen is 1, nitrogen is -3 and oxygen is -2, phosphorus is 5, S is equal to 6. And you should not multiply with what atomic sorry molecular weight, you should multiply with the elemental weights. Okay, one minute. So you people know for carbon is 4 and then what? Hydrogen is what? 1, nitrogen is -3, oxygen is -2, P is 5, S is 6. Okay. So all these are the main elements you people know the electron balance. Okay. So because you will be for this normality finding and all, you will be using this. Okay. That is equivalence, available equivalence electrons. Okay. So you will be knowing this. So maximum carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur will be there. So you people should know this. Okay, carbon 4, hydrogen 1. Okay, nitrogen -3, oxygen -2, P5, S6. Remember this. Okay. So how you should find is degree of reduction for CH4 is 1 into 4 plus 4 into 1. Okay. So that is 1. Carbon, that elemental is what? 4 plus 4 hydrogen, that is 1. Okay, so 1 into 4 plus 4 into 1 is equal to 8. So that is the number of equivalents of available electrons. That is the equivalent weight. Okay, this is the equivalent amount of electrons. So 1 into 4 plus 4 into 1 by a gram atom of carbon. How many atom of carbon is present in C? That is 1. So you can do separately or you can do at a time also. Okay, so the degree of reduction, the representation is gamma. Remember, okay, the representation is gamma. So how you can write is, so CH4, so 1 into 4 plus 4 into 1 divided by the number of available gram atom of carbon is 1. Okay, so you will have 8 by 1, that is degree of reduction is 8. Okay, and the next is C6H12O6. For this, how will you do? 6 into 4 plus oxygen is, sorry, hydrogen is 1, 12 into 1 plus oxygen is 6 into minus 2 divided by number of carbons here is 6. Okay, so 6 carbons. So gram atom of carbon is 6. Okay, so 24 divided by 6. So you will have 4. The degree of reduction is 4. So like this we have to find. Okay, so this is the degree of reduction. So you people, different concepts, you people should not get confused between the other concept and this. And this is C2H5OH, that is 2 into 4 plus 5 into 1 plus, okay, 1 into minus 2 plus 1 into 1, that is what, 12 divided by the number of gram atom of carbon is 2. Okay, that is 6. And this is not required. Okay, so this is what we have studied. So we should now go for the problem. Okay, so the problem is, assume that the experimental measurement for a certain organism have shown that cells can convert 2 by 3 of substrate carbon to biomass. Okay, and calculate the stoichiometric coefficients. Assume that experimental measurements for a certain organism have shown that cells can convert 2 by 3 of the substrate carbon to biomass. So what we have to do is we have to calculate the stoichiometric coefficient. So what is the equation given is C16H34 plus AO2 plus BNH3 gives C for, this is the coefficient, C 4.4, H 7.3, N 0.86, O 1.2 plus DH2O plus ECO2. Okay, for there are two equations. Okay, this equation hexadecane, this is the formation of hexadecane and this is the formation of glucose, and we have to calculate the yield coefficients, that is yx bar s and then yx bar o2 for both the reactions, and also we have to calculate the degree of reduction and respiratory quotient. Okay, degree of reduction and respiratory quotient. Okay, so now what we will be doing means, I will be taking an empty sheet and I will be explaining how you have to what do this. So I'll read the question carefully. Assume that experimental measurements for a certain organism have shown that cells can convert 2 by 3 of substrate carbon to biomass, and here we have to calculate the stoichiometric coefficient, that is hexadecane, formation of hexadecane and the formation of glucose. Okay, and here so let me take an empty sheet and I will explain you. Okay, so what is the equation given is C16H34 plus AO2 plus BNH3 gives C of C 4.4, H 7.3, N 0.86 O 1.2 plus D H2O plus ECO2. Okay, so this is what the equation they have given, and they have asked us to find what the stoichiometric coefficients. Okay, stoichiometric coefficients is nothing but this A, B, C, D, and E. Okay, so we have here only some 2-3 problems, and all these problems are very important. Okay, so what they have given us, first let me read the problem once again. Assume that experimental measurements for a certain organism have shown that cells can convert 2/3 of substrate carbon to biomass. What they have given here condition is 2/3 of substrate carbon. Okay, substrate carbon is being converted to biomass. This is the first condition. Okay, for this equation they have given 2/3 of substrate carbon is being converted to biomass, and they have asked us to calculate the stoichiometric coefficient. That means we have to find this A, B, C, D, E. This is all the stoichiometric coefficient, and also they have asked us to find the yield coefficients, and that is y x bar s and y x bar o2. Also calculate the degree of reduction and respiratory quotient. Okay, this is what we have to find. Okay, so this is what the equation they have been given, and they have given a 2/3 of the substrate carbon is being converted to biomass, and this is the production of what hexadecane. Okay, this is the hexadecane, and they have asked us to find the yield coefficients as well as degree of reduction and respiratory quotient. Okay, so now here what is biomass and what is substrate is, this will be always the substrate. Okay, the main compound which is present in the reactant is the substrate, and this, okay, will be the biomass, and this will be the biomass, because you will have a main equation, that is C16H34, and oxygen and this ammonia and all supplements. Okay, same way you will have a bigger element, that is here this hexadecane is our biomass, and this water and CO2 is the extra products what we have produced. Okay, so now what we have to find is stoichiometric coefficient. Okay, so for this, first what they have given is the amount of carbon converted in substrate to biomass is 2/3. Okay, suppose if this is not given, directly we will go for that. I have told you people long back that elemental balance, carbon balance, nitrogen balance and all. And suppose if this 2/3 of substrate carbon is not being given, we will be going directly to what? Identifying the balancing. But since this amount has been given, first we have to find how much amount of carbon is present in substrate, and then we have to find how much amount of carbon is being converted to biomass. Okay, so now first is amount of carbon. Okay, amount of carbon in how many mole of substrate? This is 1 mole of substrate, right? Amount of carbon in 1 mole of, sorry, I'll be little slow in writing. Okay, amount of carbon in 1 mole of substrate. Okay, amount of carbon in 1 mole of substrate is equal to how many? Okay, 16. Okay, moles is 1 only, and 16 into the molecular weight of carbon. Okay, so the atomic weight. So 16 into 12, that is 16 carbons, that is 192 grams. Okay, so the amount of carbon present in substrate is what? 192 grams. And out of this, how much amount of bean is converted to biomass is 2/3 of the substrate carbon is being converted to biomass is what given in the problem. Okay, so now amount of, same, okay, amount of carbon converted to biomass. Okay, amount of carbon converted to biomass is, you people can write clearly. Okay, so I want to avoid. So 192, in 192, how much has been converted into 2 by 3? And listen, ma, all of you, suppose if the meeting is ended in between, I will send you a link. Okay, because I cannot stop the problem such like that. So I have to finish this problem. So if the meeting is ended, I will send you one more link. All of you, please join back. Okay, 192 into 2 by 3 is 128 grams. Okay, so the amount of carbon converted to what? Biomass is 128 gram. That means the amount of carbon present in the substrate is 192 gram. That is, this is the substrate. So 16 into 12. Okay, 16 amount of carbon, number more carbon, and into the atomic weight, that is 192 gram. And they have given out of this 2 by 3rd of the substrate carbon is being converted to biomass. Okay, so 192 into 2 by 3 is what? 128 grams. Okay, so now what we have to find is, so out of this 128 gram is being what? Converted. 128 gram is being converted to 1 minute. So 128 gram has been converted to biomass. So obviously the remaining will be converted to what? CO2 only, right? The amount of carbon, remaining carbon might have been converted to CO2. No other possibility, because H2O, carbon cannot be converted to H2O. So obviously that will be converted to CO2. So next we have to find amount of carbon converted to CO2 is 192 minus 128 is equal to 64 grams. Clear? All of you clear with this, ma? So amount of carbon in 1 mole of substrate is what? 192 grams. And they have given 2 by 3rd of the substrate carbon is been converted to biomass. So this, okay, carbon, out of this 198 grams of carbon, 2 by 3rd is 192. 2 by 3rd is what? Been converted to biomass. So now what we have written? So 192 into 2 by 3 is 128 grams of what? Carbon out of 192 grams is being converted to biomass. So now what will be the remaining carbon? Okay, where will be the remaining carbon? So we will see the product. So obviously that will be converted to CO2 only. There is no possibility of carbon getting converted to H2O. So the amount of carbon converted to CO2 is 192 minus 128 is equal to 64 grams. Okay, and this is what? Only for carbon. Okay, this method, whatever we are doing, only for this. If this problem is given, 2 by 3rd of the substrate is being converted to biomass. Okay, now what we have to do means, so first we have to take only the carbon and then we have to balance it. Okay, so the amount of carbon converted to biomass is 128. Okay, 128. Okay, and then what is the amount of carbon present in the biomass according to the equation? Okay, so this is coefficient is C, the number of carbon present is 4.4, okay, into the atomic weight is 12. Okay, because only the carbon present in biomass is 128. So this 128, we will be taking only the carbon present in the biomass. We will be equating it to the carbon present in the biomass. That is 128 is equal to the stoichiometric coefficient is what? C, and the number of carbon, the amount of 4.4 into the atomic weight of carbon, that is 128 is equal to C into 4.4 into 12. So what you will get is C is equal to 2.42. Okay, C is equal to 2.42. And same way, this 64 gram is being what? Present, the carbon present in CO2, right? How much amount of, so the amount of carbon converted to CO2 is 64 gram. So you should take this 64 gram and equate it only the carbon present in the CO2. Okay. So now 64 is equal to E into 1 into the amount of carbon present is 12. Okay. So now we will get E is equal to 5.33. Okay. E is equal to 5.33. Clear? This till this the concept is clear. E is equal to 5.33. Okay. So since this point is given, that is 2/3 of the substrate carbon is being converted to biomass, we have done this. Okay. So first we have found how much amount of carbon present in 1 mole of substrate. That is 16 into 12 is equal to 192 grams. Out of this 192 grams, how much is being converted to biomass? Okay. That is 192 into 2/3, that is 128 grams. Okay. And then the remaining, see, we have to see the product equation whatever they have given. So they will give CO2. Okay. So the amount of carbon converted to CO2 is 192 minus 128 is 64 grams. Now we know the amount of carbon present in biomass as well as CO2. So you equate it to the carbons, only the carbon which is present over there. So 128 is equal to C into 4.4 into 12. C is equal to 2.42. We have found one stoichiometric coefficient, that is C. Okay. And the next is 164 is equal to E into 1 into 12, that is E is equal to 5.33. Okay. So now almost carbon balance is done. So now let us start with nitrogen balance. Okay. So what now the normal balance, how what I have taught you. Okay. So now we have to go for nitrogen balance. Okay, now I have to go for nitrogen balance. Okay, so how it is nitrogen. See how many amount of nitrogen is present. Okay, so B into 1 into 14. Okay, B into 1 into 14 is equal to, we will see here, C into, remember you have to multiply with the molecular weight also. Okay, that is just an elemental balance. This is a material balance. Okay, so 0.86 into 14 atomic weight. Okay, C into 0.86 into 14. So this is what? Okay, so when you solve, you will get B is equal to 2.085. Okay, B is equal to 2.085. Now the next what will we go is, because already we have taken hydrogen, we have not gone direct carbon, we have not taken, we to go into carbon balance. Okay, so we have gone into nitrogen balance. So B into, so reactants. Okay, B into 1 into 14 is equal to here C into 0.86 into 14. So over N, and the next is what? Hydrogen balance. Okay, hydrogen balance. Next is hydrogen balance. So here you will have hydrogen balance is 34 into, oh sorry, 1 into 1. Okay, so plus B into B 3 1. Okay, plus B into 3 into B into 3 into 1 is equivalent to C into 7.3. If you have any doubts, you can ask mine between C into, I think another 1-2 minutes, the meeting will end and I will send a new link. All of you please join. Okay, C into 7.3.
Ma'am, we have a doubt, ma'am.
Tell me, ma. Plus,
Ma'am, how this value came, ma'am? The 2/3.
they
This
have
is
given in problem 2/3 of the substrate is being converted to biomass. That is a question.
okay.
Okay, B into
Okay.
2 into 1. Okay, d into 2 into 1. Okay, so now from here you know all the other values, so you will get, when you substitute the other values and solve the equation, you will get d is equal to 11.29. Okay, d is equal to 11.29. So c is being found, e is being found, b is being found, and d is being found. So only one thing we have to find is a. Okay, so we have to write, okay, I will write here. 1 minute. So if I move also, it will not come up. So oxygen balance. Okay, for that we will go for oxygen balance. Okay, so oxygen balance is, so A into 2 into atomic weight of oxygen is what, 16, is equal to, okay, so here oxygen is C into 1.2 into 16, okay, plus D into 1 into 16 plus, okay, D into 1 into 16 plus again E